Overcurrent protection devices, such as circuit breakers, are installed to protect conductors from overheating in the event of excessive current flow. The overcurrent protection device provides a maximum amount of current that can flow before it trips and opens the circuit. Conductor ampacity is the maximum amount of current that a particular conductor can safely carry without overheating. For example, a number 12 AWG copper conductor has an ampacity of 20 amps in a 90 degrees Celsius environment. The National Electrical Code requires that the overcurrent protection device be rated to protect the conductor from damage under normal operation. In general, the overcurrent protection device should not exceed 125% of the conductor's ampacity. In the scenario where you have a number 12 conductor wired to a 30 amp circuit breaker, according to the National Electrical Code, this is generally not permitted. A number 12 conductor has an ampacity of 20 amps, and the overcurrent protection device should not exceed 125% of that, which is 25 amps. Using a 30 amp circuit breaker on a number 12 conductor could lead to overheating and a fire hazard. It is important to adhere to the National Electrical Code guidelines to ensure safety and prevent potential hazards. Firstly, understand the role of overcurrent protection devices. These devices, commonly circuit breakers or fuses, are crucial components in electrical systems. Their primary function is to safeguard conductors from overheating and potential damage caused by excessive current flow. Think of them as safety valves, designed to interrupt the electrical circuit when the current exceeds a predetermined safe level. Secondly, grasp the concept of conductor ampacity. Every electrical conductor, such as a wire, possesses a specific ampacity rating. This rating signifies the maximum amount of electrical current, measured in amps, that the conductor can safely carry without experiencing detrimental heating. The ampacity of a conductor is influenced by several factors, including its material, size, insulation type, and the surrounding ambient temperature. For instance, a number 12 American wire gauge copper conductor, a common size in residential wiring, typically has an ampacity of 20 amps when operating in an environment with a temperature of 90 degrees Celsius. Thirdly, adhere to the National Electrical Code requirements. The National Electrical Code, a widely adopted standard for electrical installations, provides comprehensive guidelines to ensure electrical safety. The National Electrical Code mandates that overcurrent protection devices must be selected and installed in a manner that adequately protects conductors from damage during normal operation and fault conditions. A fundamental principle outlined in the National Electrical Code is that the rating of the overcurrent protection device should not exceed 125% of the conductor's ampacity. This principle ensures that the conductor is protected from overcurrent situations that could lead to overheating and potential fire hazards. Now, to address the specific scenario of using a number 12 conductor with a 30 amp circuit breaker. According to the National Electrical Code, this configuration is generally not permitted. As previously mentioned, a number 12 conductor typically has an ampacity of 20 amps. Therefore, the overcurrent protection device protecting this conductor should not exceed 125% of 20 amps, which equates to 25 amps. Using a 30 amp circuit breaker on a number 12 conductor violates this fundamental principle and creates a potential safety hazard. The consequences of using an oversized overcurrent protection device on a conductor with a lower ampacity can be severe. When the current in the circuit exceeds the conductor's ampacity, the conductor will begin to overheat. This overheating can degrade the insulation surrounding the conductor, leading to insulation failure and potential short circuits. In extreme cases, the overheating can ignite nearby combustible materials, resulting in a fire. To illustrate this concept, consider a scenario where a number 12 conductor is connected to a 30 amp circuit breaker. If the circuit experiences an overcurrent condition, such as a short circuit or an overload, the current may rise significantly above 20 amps. While the number 12 conductor is only rated to safely carry 20 amps, the 30 amp circuit breaker will not trip until the current reaches 30 amps. During this time, the number 12 conductor will be subjected to excessive current, causing it to overheat. If the overcurrent condition persists long enough, the conductor's insulation may fail, leading to a short circuit or a fire. It is crucial to understand that the purpose of the overcurrent protection device is to protect the conductor, not the load connected to the circuit. Therefore, the size of the overcurrent protection device should be determined by the ampacity of the conductor, not by the current requirements of the load. Now let's discuss the appropriate corrective actions to take when encountering a situation where a number 12 conductor is protected by a 30 amp circuit breaker. Firstly, replace the 30 amp circuit breaker with a 20 amp circuit breaker. This is the simplest and most straightforward solution. By installing a 20 amp circuit breaker, you ensure that the overcurrent protection device is properly sized to protect the number 12 conductor. Secondly, replace the number 12 conductor with a conductor that is rated for 30 amps. If you need to use a 30 amp circuit breaker for a particular load, you must use a conductor that is rated to safely carry 30 amps. A number 10 American wire gauge copper conductor is typically rated for 30 amps and would be an appropriate replacement for the number 12 conductor in this scenario. Thirdly, it is important to consider the specific application and the nature of the load being served. Some appliances, such as air conditioners, may have specific overcurrent protection requirements that differ from the general rules outlined in the National Electrical Code. In these cases, it is essential to consult the appliance manufacturer's instructions and the National Electrical Code to determine the appropriate conductor size and overcurrent protection device for the specific application. Now let's discuss some additional considerations related to conductor ampacity and overcurrent protection. Firstly, dirting factors. In certain situations, the ampacity of a conductor may need to be derated, meaning that its maximum allowable current is reduced. Derating factors are applied when conductors are installed in an environment with high ambient temperatures or when multiple conductors are bundled together. These factors account for the increased heat generated by the conductors and ensure that they do not overheat. Secondly, voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause appliances to operate inefficiently or malfunction. The National Electrical Code provides guidelines for minimizing voltage drop in electrical circuits. Thirdly, grounding. Grounding is an essential safety measure in electrical systems. Grounding provides a lower impedance path for fault currents to flow back to the source, allowing the overcurrent protection device to trip and to energize the circuit in the event of a ground fault. Fourthly, arc fault circuit interrupters. Arc fault circuit interrupters are specialized circuit breakers that are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. Arc fault circuit interrupters are required in many areas of the home, such as bedrooms and living rooms, to provide enhanced protection against electrical fires. The National Electrical Code provides detailed requirements for the installation and use of arc fault circuit interrupters. Fifthly, ground fault circuit interrupters. Ground fault circuit interrupters are designed to protect people from electrical shock. Ground fault circuit interrupters detect ground faults, which occur when current leaks from a circuit to ground. Ground fault circuit interrupters are required in areas where there is a high risk of electric shock, such as bathrooms and kitchens. The National Electrical Code provides detailed requirements for the installation and use of ground fault circuit interrupters. Sixthly, conductor terminations. Proper conductor terminations are essential for ensuring safe and reliable electrical connections. Loose or corroded connections can cause overheating and potential fire hazards. Conductors should be properly sized and terminated using approved connectors and methods. Seventhly, electrical panels. Electrical panels are the central distribution points for electrical circuits in a building. Electrical panels should be properly labeled to identify the circuits they serve. Electrical panels should also be kept clear of obstructions to allow for easy access and maintenance. The National Electrical Code provides detailed requirements for the installation and maintenance of electrical panels. Eighthly, permits and inspections. In most jurisdictions, electrical work requires permits and inspections. Permits ensure that electrical work is performed in accordance with the National Electrical Code and other applicable regulations. Inspections verify that the electrical work has been properly installed and meets safety standards. It is important to obtain the necessary permits and inspections before performing any electrical work. 9. Qualified electricians. Electrical work should only be performed by qualified electricians. Qualified electricians have the knowledge, skills, and experience to perform electrical work safely and in accordance with the National Electrical Code. Hiring a qualified electrician is essential for ensuring the safety and reliability of electrical systems. 10. The importance of continuous learning. The field of electrical work is constantly evolving with new technologies and regulations. Electricians should continuously update their knowledge and skills to stay abreast of the latest developments. Continuing education courses and professional development opportunities can help electricians stay current and maintain their expertise. In conclusion, understanding the principles of overcurrent protection, conductor ampacity, and the National Electrical Code is crucial for ensuring electrical safety. The scenario of using a number 12 conductor with a 30 amp circuit breaker is generally not permitted by the National Electrical Code due to the potential for overheating and fire hazards. By adhering to the National Electrical Code guidelines and employing proper wiring techniques, you can create safe and reliable electrical systems.